Let's look at the most simplest flip-flop, which is the D flip-flop. The symbol for the D flip-flop is as follows. So you have D input, Q, Q prime. It's pretty much similar to the D latch. And then you have the clock. So this is the symbol for the clock. The internal diagram of a D flip-flop is as follows. It's going to contain two gated D latches. So that's latch 1, Q, Q prime. Have the second latch, D, G, Q, Q prime. And you have a clock. So the first gated input of the first latch is given the inverse of the clock, and the second input for the latch, or the second gated input for the other latch, is given the clock, and you have D as your input and Q as your output, and you also have Q prime as well. So this is the internal diagram of a D flip-flop. Now I'm not going to tell you how this is going to work internally, but I'm going to give you the truth table to see how it works. Basically, the truth table is very much similar to what you have for a D latch. So you have D, Q, Q plus, so 0, 0, 0, 1, 1, 0, 1, 1. Now remember, this is a positive edge triggered flip-flop. This information will be given to you, which means that at the rising edge of the clock, whatever value is here, it's going to get shown. It's going to show up here. So assuming that you have a positive edge of the clock, if D is 0 and Q is 0, then output is 0. If D is 0 and Q is 1, output is 0. If D is 1 and Q is 0, output is 1. And if D is 1, output is 1 again. So that's the D flip-flop, or the D latch as well, in fact. The only difference would be the rising edge of the clock cycle, or the clock signal. That is when a D flip-flop operates. As you can see here, the output of a D flip-flop always follows the input. Let's take an example or two and see how this works. Given here is a rising edge triggered D flip-flop with the following inputs. So you have D and clock, and you're asked to sketch Q, and we are going to assume that Q initially starts at 0. Now we only look at D at the rising edge of the clock, and if you see here, there are 4 rising edges: edge 1, edge 1, edge 2, edge 3, and edge 4. So only at these rising edges, we are going to sample the value of D and then send it to the output. So until the rising edge of the clock, it's going to maintain its value. At this rising edge, D is 1. So after a slight delay, you're going to see Q go to 1 as well. It's going to remain 1. Now at this rising edge, D is a 1. So Q remains as a 1. At this rising edge, D is a 0. So after a slight delay, your Q is going to go to a 0. At the next rising edge, your D is 0 again. So just keep holding the value. So this is the working of a D flip-flop. Let's look at the second example. So we are given the rising edge triggered D flip-flop, and we are asked to sketch Q. Here Q is 1. It starts at 1. So again, first mark the rising edges. So edge 1, edge 2, edge 3, and edge 4. At edge 1, until edge 1, we are going to hold the value of Q. At edge 1, D is 0. So after a slight delay, your Q is going to go to a 0, and you hold it. At the next rising edge, D is 0 again, so nothing changes. At the next rising edge, D is 1. So after a slight delay, Q goes to 1. At the next rising edge, D is a 0. So after a slight delay, Q goes to 0. Let's take the final problem. Now here it says repeat problem 2 with the assumption that the flip-flop is now falling edge triggered. So for a falling edge triggered, you have to consider the negative edges, which is this edge, this edge, this edge. So here we have only 3 clock pulses. So initially your Q is going to hold its value. At this stage, D is 1, so hold value. At this falling edge, D is a 0, so after a slight delay, it goes to 0. Hold it. At this falling edge, D is again 0, so hold the value. So this is how a D flip-flop works.